Question 19. In this question, it will define pressure as the perpendicular component of a force on a surface divided by the area of the surface. The equation is P equals F over A. Pressure has a symbol P and a unit of Pascal. It is the perpendicular component of a force on a surface divided by the area of that surface. The pressure is a scalar value. That means it has only a magnitude, and its unit is Pascal, where 1 Pascal is equal to 1 Newton of force divided by an area of 1 meter squared. The equation for pressure is force measured in newtons divided by area measured in meters squared. So this A is area measured in meter squared, and F is the force measured in Newton. Sometimes it doesn't give me the force of the object or the force applied by the object. He gave me the mass of the object. If he gives me the mass of the object, I will multiply it by 9.8 to find the weight of the object. That's the force applied on the area. Sometimes it doesn't give me the area straightforward. I need to find it. If the area is a rectangle, I will multiply length times width. Sometimes the area is in centimeters squared. To convert it to meters squared, I need to divide it by 10,000. If it's in meters squared already, don't do that. Only if the area is in centimeters squared, you'll divide by 10,000. In this question says a child that weighs 364 newtons and he sits on a three-legged stool with a weight of 41 newtons. The bottoms of the stool's legs touch the ground over a total area of 19.3 centimeters squared. What is the average pressure that the child and the stool exert on the ground? And how does the pressure change when the child leans over so that only two legs of the stool touch the floor? Before we start with solving for A, we need to find the total force applied on the area. The weight of this person and the weight of the stool are the forces acting on the area of the area that the legs make with the ground. So the total force applied on the area is the sum of their weights. So it's the weight of the child plus the weight of the chair. 364 plus 41 gives you 405 newtons. This amount of force is applied on an area, a total area of 19.3 centimeters squared. Since we have in centimeter here, we need to turn it into meter by dividing over 10,000. So we'll get 1.93 times 10 to the negative 3 meters squared. Now after we prepared the area and the force, let's solve for A. In A, he wants me to find the average pressure applied by the stool and the child on the ground. So we'll apply P equals F over A. The force is 405 and the area is 0.93 times 10 to the power of negative 3. That gives you a 209,844.5 Pascal. In B it says, now this person leans over and only two legs touch the floor. So one of the legs were cancelled. That means that the area has decreased. And if you look at the equation, you can see that the relationship between the pressure and the area is an inverse relationship. One is in the numerator and the other is in the denominator. So the relationship between them is an inverse relationship. Here, the area decreased, so obviously the pressure will increase. Now, since one of the legs, or since the total area is spread over three legs, each leg has 1/3 of the total area. If one of the legs is deleted when he leaned over so that only 2 legs touched the ground, one of the legs was deleted, so 1/3 of the area was deleted. We are left with only 2/3 of the area. So we need to find the new area by multiplying the total area by only 2/3, which is the area of 2 legs. That will give you a 1.28 times 10 to the negative 3 meters squared. So this is the area of that the stool makes with the ground after the child leans over. Now, after we found the new area, we were going to apply the pressure equation again to find the new pressure. P equals to F over A. The force applied is still the weight of the child and the chair, so 405, divided by the new area, which is 1.28 times 10 to the negative 3. After dividing, you can see that the pressure has increased. Since the area has decreased, the pressure will increase. I gave you an example in the exam. I gave you another question where a person was standing on 2 legs and then he lifts one leg up. When he lifts one leg, the area becomes half of its total area. That means that the pressure will be twice as much. Remember, inverse relationship. If the area becomes 1/2, then the pressure will be twice its amount. So this is the first example. A lead brick has dimensions of 5 centimeters, 10 centimeters, and 20 centimeters, and it rests on the ground on its smallest surface, or on its smallest face. Lead has a density of 11.8 grams per centimeter cubed. What pressure does the brick exert on the ground? So here عندنا طوبة من الرصاص، وهاي الطوبة إلها أبعاد 5 في 10 في 50. This brick lies or is sitting on the ground on its smallest face. That means these dimensions are 5 and 10. And this dimension right here, that's 20, because it's sitting on its smallest face. Of course, all of them are in centimeters. Given in the question are the dimensions and the density. Now the density كثافة المادة تساوي كتلتها على حجمها. Now here, given the density in gram per centimeter cubed. So that means that the mass used to find the density was in grams and the volume was in centimeter cubed. The density given was 11.8 grams per centimeter cubed. So this is the density, and this is the length, width, and height of the brick. He wants me to find the pressure that the brick exerts on the ground. If I want to find the pressure, I need to divide the force of the brick, which is the same as its weight, divided by the area it makes with the ground. So here we need to find two things. We need to find the weight of this brick, which resembles the force applied on the area, and we need to find the area of the smallest face. Now to find the weight of the brick, I need to multiply its mass times g. But I don't have the mass. Let's write it here so that we have more space. So here, this brick is exerting a force equal to its weight on that area. I need to find the gravitational force or the weight of the brick, which is the force applied on the area. So I need to multiply its mass times 9.8. but in the question there is no mass. So from where do I find the mass? I will find it from the density equation. The density is 11.8. The mass is the unknown, and the volume of the object is equal to length times the width times the height. So it is 5 times 10 times 20. Rearranging the equation or using the shift solve on the calculator, we will see that we'll put x here because we need to find the mass. 5 times 10 times 20. Shift calc equal. You'll see that the mass is 11,800 grams. See, the unit is in grams. So the mass is 11,800 grams. Now remember, grams is not the base unit. The base unit for mass is kilograms. So we need to convert from base to kilo. If you go back, to convert from base unit from grams to kilograms, we need to divide by 1,000. So here we're going to divide the mass by 1,000 to turn it into kilograms. It becomes 11.8 kilograms. Now that we have the mass, we can find the weight subjected, or the weight that exerts the force on the area. 11.8 times g, which is 9.8, gives you 115.64. So this is the amount of force applied on the area. Now what is the area of the smallest face? We need to find the area of the smallest face right here. You can see that the smallest face has the dimensions of 5 and 10. So to find the area, I have the force, there it is. We need the area, which is equal to 5 centimeters times 10 centimeters. And that's going to give you a 50 centimeters. Now this is in centimeter. I need to turn it into meter by dividing over 10,000. That will give you 1, 2, 3, 4. It's going to give you an 0.005 meters squared. You can use the calculator in order to validate the answer. That's the same number. Now that I have the area and the force, we will apply the pressure equation. Using the calculator, 115.64 divided by 0.005. That's 23,128. You can turn it into kilopascal by converting from base to kilo, dividing over 1,000. So that's going to give you 23,128 kilopascal. So this question is a multiple process question. Here you need to find the mass first using the density equation. Then find the mass in kilograms by dividing over 1,000. Then use the Fg equals mg equation to find the force applied on the area. And then you need to find the area of the smallest face by multiplying length times width, dividing it over 1,000 to turn it from 10,000 to turn it from centimeters squared to meters squared, and then after that using the pressure equation to find the pressure. So you can see that this is quite a question with a lot of steps.